welcome to the Global Bizapps Day 2020, powered by the D365 Champs. I'm Roma Gupta, all the way from South Africa. Hope you are doing well, keeping safe, and you are enjoying our session so far. Stay tuned. Today's session, which is now being presented by Allan Pead, he will be talking about automating your home or office with IoT Central and PowerApps. He loves mobile, gadgets, and robotics. He's an electric engineer turned into software developer. Pretty cool, right? He assists the community globally on Xamarin and .NET projects and more on IoT and electronic space. So before I hand over the session to Allan, I would like to mention that if you have any question, please feel free to drop it in the chat window or raise your hand, and we will take it during the session or if possible during the Q&A time. Thank you for joining everyone and enjoy the session. Allan, over to you.
Thank you very much, and thank you very much for having me. I love talking, so thank you very much for allowing me to speak. So yeah, thank you very much. And this is a topic that I love speaking. So hopefully it will be interesting for everyone. Right. Can you just confirm that you can see my screen and it's shared okay?
Yes. Yeah.
Cool. Right. Let me kick off. Right. So I've already had the introductions, but I'll just give the intro of myself. So my name's Allan Pead. I'm a Microsoft Developer Technologies MVP, a Microsoft Azure MVP, and a Xamarin MVP. The Xamarin MVP came from a very long time, and I will always keep that badge. So definitely that's my favorite. What I do is I build stuff on the Microsoft stack as a day job. So what I really enjoy is my passion and what I really like is actually my day job. And I've been building software since I think it's now 1994. So all that makes me is old. So yes. Then the MVP title, that just means that I really enjoy helping people build stuff as well on Microsoft Stack and becoming successful with the Microsoft Stack as well. So in doing that, I'm also very much involved in the Microsoft community groups. I help organize the Microsoft developer groups in South Africa. So these logos here at the bottom, you can also follow their Twitter handles as well. So the logo is the Twitter handle, so that's very convenient. So we run 3 user groups in 3 cities in South Africa. So that's another interesting fact is I'm from South Africa. And we run it in Cape Town, Johannesburg, and Durban. If you want to drop by, we run these user groups every month, like clockwork. Okay, so a little bit more about me, and I won't bore you too much, but I have some weird hobbies. As you saw, I have been doing software development for a very long time, and also means that yes, I'm old, and I have these weird hobbies of collecting old computers from the 1980s. So I have a whole pile of them, and I'm getting more and more by the day. My desk usually looks like this. This is actually what my side desk here looks like in the office right now. I build IoT things for fun, and I build IoT things for events and things like that. But also these little fun devices also become prototypes for real production solutions as well. So it's really cool to build IoT things for industry, and you get to build really fun things, and you can play with these gadgets, and you can experiment with things like AI and IoT and all those type of things. So what is this talk about? So the reason why I put this talk together is, as you see, I'm very much into coding. I write lots of code, and everything I build has lots and lots of code involved. So what I thought was, how about looking at building IoT solutions without any code, or as low code as possible? So what I'm going to be speaking about today is low-code Internet of Things, also translating that into home automation, home and office automation. It also plugs into what I did when I moved into my home office during this COVID pandemic. So it all comes together into this talk. Also, as I say, I write lots of code. I enjoy code, and Visual Studio is my safety blanket and Visual Studio Code. So this is all out of my comfort zone, but let's see how it goes. Right. What we're going to be speaking about in this talk is something known as IoT Central, PowerApps. I see it was featured very, very often today, so we will be looking at PowerApps in context of IoT, looking at a platform called Node-RED, and looking at using as little code as possible to make IoT devices work. And in other words, when we say low code, we also mean low work IoT devices to make things just work easily. Okay, so the plan was, I have this application, it's on the internet, and I have my house. I have some switches in my house that I want to switch on and off. I have some light switches, air cons. I have many more switches that's in this diagram. I've got a water tank outside that pumps rainwater. I've got hydroponics in my garden shed and things like that. So I've got lots of switches. But in this talk, we're going to speak about just some light switches and powering our aircon. And something that was very important to me when we all moved home during the pandemic is like we're all working from our home offices and things like that. How safe is your home office? How clean is your air? And what are you breathing every day that you get out of bed, you roll down the stairs, you end up in your home office, like you're breathing this every day. So I'll look to install a air quality monitor within the office as well. So the idea was this application is on the internet. It switches things on and off and controls things and automates things within the house. And I'll get some telemetry as well from different devices in the house. In this talk, I'll be focusing on an air quality monitor. Okay, so then the plan had to evolve. So that was the rudimentary plan. And then there was part 2 of the plan. This application on the internet, I don't really want to speak to my switches directly, and I'm not sure how I was planning on doing that. And of course, this air quality monitor also is not exposed to the internet. So what has to happen is something that sits there, basically a cloud broker or an internet broker of some sorts. Some terms as IoT hub. Something that also speaks MQTT, which is very important in IoT. It's message queuing telemetry transport. So something would have to speak that type of language for me to read telemetry and me to be able to switch things and so I have something useful from the internet to control my house. So then what happened in part 3 of the plan is I had to extend it into something like a gateway. So I want something in my house to control what's being controlled from, which is being triggered from the outside world. And I want to distribute messages from the internet through one conduit so that I don't have all these switches and things connecting directly to the internet. It's probably a bad idea exposing all of the things to the internet. So I was thinking about, okay, part 3 of the plan, let's extend it to what's known as a gateway. So a gateway is basically a gatekeeper to multiple devices, and its job is to distribute messages from whatever is sending the messages. We haven't fleshed that part out yet, to the switches, and they would then switch things on, switch the lights on, switch the aircon on, and so forth. Right, so then it fleshed out into the final plan, how I'm going to do this and with what I'm going to do it. So that application, I'm going to build a PowerApps application to communicate with my switches and my air quality monitor. IoT Central will be that cloud hub that we have some sort of MQTT server out in the cloud that we can use for sending messages up and down. And then, of course, my gateway needed to be implemented. It could be a hardware gateway put down. It could be a software gateway. But what I was thinking of, I want to do this, my original goal, low code. Everything must be low code or no code. So then I chose Node-RED to implement the gateway. Now, also something to consider, these switches that I have, I don't want to have them purely controlled by the internet. So I want to have some sort of local control as well. So for example, if I had to, in an example, like an OB example of, I want to have a switch pump water into the fish pond. If I have some sort of break in the internet, I don't want to have my favorite koi fish flowing down the road. So I need to have some sort of local control that I can be able to switch it and switch things off when I need to immediately. And of course, if there's a problem, I need it off immediately. So this is probably also a very good pattern to follow in industry as well. Always have some sort of local control and ways of controlling it. So what I opted for was a local MQTT server as well. I implemented it with something known as Eclipse's Mosquito, which is a nice, lightweight, local MQTT server. And then I was looking at the switches, and I was looking at low-code type switches as well. And there's an open source firmware known as Tasmota that runs on ESP processors and things like that. And you can flash ESP chips and stuff with Tasmota. And Tasmota gives you the ability to connect to MQTT locally as well. It also has other advantages of disconnecting you from the actual manufacturer's firmwares as well. But in this case, we want to have just a local network speaking to MQTT, and Tasmota would definitely fit that mold. Right, so for just simplicity, the air quality monitor, you can see it's bypassing the gateway. It's connecting directly to IoT Central. It could go through the gateway as well, but in this case, we're going to connect it straight to IoT Central. Right, so to start, I installed the gateway, and that gateway is Node-RED. And you notice here in that image on the top of the screen, it's got a big heatsink. So that's obviously a Raspberry Pi 4 because it runs really hot. So I decided, well, I've got this Raspberry Pi. I can then deploy Docker containers onto this Raspberry Pi. This is also an 8 gig Raspberry Pi, so it's got plenty of RAM as well. And it's doing quite well. It's even running things like IoT Edge, and it's running SQL on the edge, and it's running all my home automation as well, which is quite nifty. So to get Docker to run Node-RED, it's very simple. You can go to Docker Hub and you can download. You can just get the Node-RED image, and it's actually stupidly simple to get up and running. You basically can just run the image. The important thing to note is I'm specifying here in the Docker run command, I'm mounting a volume because I want to also externalize the configuration for the gateway, because I want to have a persistent storage, not transient storage. So in other words, when I shut down my image, I want to have everything I configured in Node-RED to exist. And that's the only the real thing that you have to worry about is how to set up a volume. So all this is mapping the internal config within Node-RED's Docker container to my own system. Then the next thing to do was install Mosquito, so also a Docker container. And you can then install Eclipse's Mosquito quite easily. And again, the only thing that you really need to take note of is the configuration needs to be persisted. So we're mapping a volume here so that we're mapping the internal Mosquito configuration logs and data folders. We're mapping those to the real device's storage. So if the container closes, we don't lose our configuration. But deployment doesn't have to be a Raspberry Pi. I just chose it to be a Raspberry Pi. This is also my playing home automation server as well. I do have a real, in quotes, production system of my home automation. That's actually running on a Synology DS920 NAS. What's nice about that, it's running 24/7 and it's backing up all my systems and things like that onto NAS drives. And it has the capability of running Docker containers. So I can run the same images basically on a NAS as well. But if you don't have a Raspberry Pi, you can then run it on a server or anything that makes you happy that you can deploy to. It doesn't have to be a Raspberry Pi. Okay. Then I moved on to devices and chose devices. So what you see here is what's known as Sonoff devices. So Sonoff's a manufacturer. And these devices are basically intelligent switches or just smart switches. In essence, they just relays that's used to switch high voltage, high current. They normally support at least 10 to 16 amps. So you can then power relatively significant AC devices and things with them. So what's really cool about these, they low work, low code, which is my actual goal of everything I want to do here, because they pretty much work out of the box. What's really nice is that's the 4-channel Sonoff at the bottom. You can basically have one device running and you can switch independently 4 different devices as well. So they're quite powerful in what you can do, and they do make your life a lot easier. And what also is great about them is they have ESP 8266s in them, which also means that we can flash them with that Tasmota that I was looking at. And the Sonoff devices, when you get them out of the box, you can they work with something known as wheeling, which also attaches you to some of their services as well. What Tasmota does as well, it removes that link from the manufacturer and it's running purely whatever you want it to do. And I really like it from a security perspective that I can run the Tasmota firmware and I know it's only speaking to my own MQTT server and things like that. So it's really, really nice to use Tasmota with it. And when you actually done the flashing, Tasmota gives you it's basically a little server that's running on the device, and you've got a web interface. You can interact with it. You can switch things on and off yourself. It's got configuration, and it also allows you to do things like firmware upgrades and different things like that. Right. So I did say it works pretty much out of the box. The only catch is you just got to put Tasmota onto it, and the way you can do that is you can flash it with either USB to TTL cable. So in other words, a USB serial cable, which actually has these little jumpers here, these little plugs. You can do that. You can also use a Raspberry Pi because a Raspberry Pi has a serial port as well, and you can just link up the TX-RX plugs within the little Sonoff device, and you can flash it with a Raspberry Pi. There is a link here at the bottom if you're interested in doing that with a Raspberry Pi. It's pretty simple to do. And what's nice is you only ever have to flash it once, and then after that, you can then do any updates to Tasmota over the air. And of course, you can do it via its own web interface. And there's also something known as Tasmota admin, which then can coordinate the updates. So you only have to do this once. Although it is really fun, especially if you like messing with these devices. Right, so the important thing is once Tasmota is installed, you can set up the host name, which is for the MQTT server. You can set up the ports. And the important thing here is the topic that you specify on a Tasmota device is the name of the device that you will be referring to. And there's also something known as a full topic, and that full topic can basically, in my case, I've specified that it's in my house, and then the topic is a variable. So percent topic percent is a variable. So it's basically my house, son of light, and the prefix I put on the end because it just purely makes sense to me that I have a building, a device, and then the prefix is the commands, in this case, suffix, but would be the command I want to run. So in other words, I want to power it on, would be the prefix. We will be using this later when we do the demo. Then the Office Quality Monitor. You also get off-the-shelf hardware as well that you can just put down. Get some of those Sonoff devices as well that does some sort of temperature, pressure, and humidity sensing. But what's I really liked was this Enviro Plus device. It's a Pimoroni product, and it did everything that I wanted to measure in the air. So it does things like temperature sensing, pressure sensing, or air pressure sensing, humidity, light. What's nice is you can get this to determine how much light is entering the room, and of course you can switch things on and off based on light intensity. Proximity, it also can detect how close you are to it as well, and you can switch things on and off based on proximity, like human proximity to it as well. And for my air quality, it has gas sensors, so it can measure what types of gases is in the air. And it has something that's really cool, which is a particulate matter sensor, which determines what particles in the air as well. So particles in the air can cause breathing problems. You can measure causes effects on lungs that causes asthmas and things like that. So it has a particulate matter sensor as well. What's behind this little board is actually a Raspberry Pi Zero. So it also packs into a nice little form factor that runs on low power as well, which is pretty cool. But I did cheat a bit. I wrote the firmware for this. It was in Python, so that made me happy. But what IoT Central needs is basically just a firmware that can give messages in JSON in the format that IoT Central expects. And yes, I did cheat a bit and I used some code there, but this is basically the equivalent of an off-the-shelf product that you could put down as well, and you don't care about the firmware and treat it as low code. Okay, so let's move over to IoT Central, but taking a step back. Azure's got an IoT solution, which is known as IoT Hubs. IoT Hubs are there for you to establish bidirectional communication, and it's scalable to billions of IoT devices, and it works with familiar platforms and protocols. They're all standard protocols that we have here, but the one that's very important to me is MQ telemetry transport, or message queuing telemetry transport, or MQTT. It also adds security to IoT as well, which is often something that's forgotten. So it does device identity. It's then also adds that little bit of over-the-wire security as well, and adds things that's generally missing from IoT solutions. And if you've got hundreds and thousands of devices as well, it provides device management that you can manage all those devices that's out there. So how IoT devices, Azure IoT Hubs works, there's a device to cloud endpoint and there's a cloud to device endpoint, which just gives you the bidirectional communication. There's method endpoints where you can call commands or methods within a device. There's gateway support. So if you've got a device that can't speak IoT Hubs, so maybe it doesn't do TLS 1.2, or you have a device that speaks RS485 or 232 or something, you have that device speak to a gateway, and that gateway speaks IoT Hubs. Then on the right side is how those devices connect to the rest of Azure. So there you can have endpoints that go to service buses and things like Azure Functions and whatever else under the sun that you want to call within Azure. And what's also provided is how to provision devices, in other words, how to create devices with identities, and you can also manage those hubs as well. It has device support for pretty much anything out there. So whatever your device is, you can pretty much get it to connect. Doesn't matter what it is. Now, the catch though is the IoT hub is just a very small part of the solution. It's a very important part because it does all the management and distribution of messages and things. But your IoT solution, and what we're looking at here is an IoT reference architecture, consists of much more things. So maybe you want to do some analytics and put it into a dashboard. Maybe you want to have user management on top of that and connect users to groups and allow different aspects of viewing reports. You might want to distribute things to logic apps. You might need to do some data transformation and storage and machine learning and things. So things get complicated very quickly. So that's where IoT Central comes in. So IoT Central makes it fast and easy. You can start in minutes and create a finished product quickly. It implements that reference architecture, so it's scalable and secure, and it's seeing it's built on those reference architecture. It's scalable as well. Where it fits in, it's software as a service. It plugs in with the rest of the building blocks, which you see at the bottom of Azure. And then you also have some platforms as a services as well, which gives you remote monitoring, maintenance, and things like connected factories and things like that. Those are out of the box solutions that you can just say, well, I've got a factory, put it down, and that solution just works. So that plug extends into Solution Accelerators. So you can just put out of the box solutions like remote monitoring, connected factories, predictive maintenance, and device simulation. So if you don't have devices, you can then simulate devices. And how that works with IoT Central is your devices, basically you model your devices into IoT Central. You don't have to write code. You model things like telemetry. So what the telemetry looks like, you model the device commands, you model things like device properties. So properties might be things like fan speeds or things like more information about the device as well. So maybe the manufacturing information or things like that. You can also take those models that you create in IoT Central. You can also then simulate devices. So if you don't have a device, you might want to simulate devices, and you can simulate the larger devices. And it's also versionable as well. So something important to note is if you change interfaces to devices, each of those needs to be a version. And then, of course, if you're doing this manually, it becomes a mission to know which devices or which version. IoT Central manages versioning on devices as well. It also supports something known as IoT Plug and Play. And probably familiar with Windows Plug and Play, where Windows has a standard definition of a device which it understands. And of course, IoT Plug and Play follows a similar concept, that there's a standard way of defining what a device is, and it works also with IoT Plug and Play. So device templates can have capabilities. Those capabilities can be things like sensors, like in this example here, it could be temperature, pressure, humidity, and all those nice things about air quality and gases that I was speaking about before. It could be commands, so I could action something, so I could switch something on or switch something off. And then with this, you can model types and units of telemetry as well. So units would be something like temperature would be degrees Celsius and so forth. And each of these can be versioned as well. So you can have, as time changes, your device might have different capabilities, and each of those can be versioned. So as that changes over time, you can then push out different versions of devices and manage which version of the device is using which interface. So commands, you can invoke methods on a device and commands on the device. It works with a request as well that you can model. The request is basically an input parameter. You can model a response, which you can see as an output parameter, and those can also be versioned. You also have the ability to make device dashboards. So each device can have a dashboard. You can then customize those customized dashboards for a solution across many devices. You can also have specific user-based dashboards too. So it's very configurable. All this is with drag and drop, and you can, via the UI, create nice looking dashboards with graphs and lists and things like that. So you can also then do analytics. So you can do analytics and processing over a large amount of devices over a large amount of time. So it supports analytics as well. You can also take in the telemetry that's coming in real time, and you can make decisions based on that. Like in this example, we could say, well, the temperature, if it's greater than 30, then maybe call a Power Automate function to switch on a fan or an aircon or something like that. So rules have actions that are performed, and they're based on some sort of conditions that's met. And what's supported currently out of the box is email. So we can send an email to somebody, webhook if you've got an HTTP service to call. You could call flows in Power Automate. You could call logic apps, or you could use Azure monitor action groups as well. Okay, so PowerApps. So Power Automate, for the old people, it's Microsoft Flow. Creates multi-step, you can create multi-step workflows in it. Those can be automated and triggered. And Power Automate can be triggered by IoT Central as well, and it's no code, low code, so it fits into what I was trying to do as well. We have the PowerApps canvas. So here we've got a model smart building application with telemetry, and you can switch lights on and off. What's cool is it's mobile friendly. There's a little container in the App Store that you can run. So if you want to have this as an IoT trigger from your mobile device, you can do that as well. It's also a low-code implementation as well, and you can trigger Power Automate flows, and we can then trigger our IoT devices via that as well. The link between PowerApps and IoT Central, there's a premium connector. It works for Logic Apps, Power Automate, and PowerApps itself. It's a very easy connection with IoT Central, as long as you're in the same tenant, of course, as your PowerApp. All right, so something really important is that connector needs some experimental features switched on. So it needs the enhanced formula bar. It also needs the dynamic schema switched on as well. Because why? IoT Central, everything that comes out of it is dynamic. So there's an experimental feature added to PowerApps, which gives you the ability to accept those dynamic schemas as well. Just something to note, it's currently undocumented. So if you're looking for the document on this, refer to the slide. The slide is very important. Then with that connector, we can then call things directly from the Canvas app. So in this case, we're getting some telemetry from IoT Central. The reason why it also works is we get this new feature here, which is capturing the schema, because this method here can return different types of things, and we're getting this dot value out of the schema. So PowerApps has now the ability to accept those dynamic schemas as well. That's coming out of the connector. Right, so then we move over to Node-RED. I needed a solution for my local network. So what Node-RED is a low-code programming environment for event-driven applications. So it also works with Flow. So if you're familiar with PowerApps and Flow and things like that, it's very similar. It's got a drag and drop flow designer. It supports nice things like MQTT. It supports Azure IoT. It supports Tasmota, so it ticks all that boxes. And yes, there's actually no code involved. You model flows. So this flow here, for example, what we have here in this green is actually a Tasmota device, office light. And what you can do in this flow is push on into the light will switch on. You push off into it, the light will switch off. So it's a nice flow-based design. Now, support for Azure IoT, there's components that you can get and add to the palette. You can install this Node-RED contrib Azure IoT device package, and you'll get support for Azure IoT. There's Sonov Tasmota support. If you go to Node-RED contrib Sonov Tasmota, and that will give you all the components needed for that. And then MQTT support is out of the box, so you can do actions based on telemetry coming in, and of course you can put messages on the MQTT bus as well. Right. So what we can also do, and this is what I'll be doing next in a demo, is we've got Node-RED configured as an IoT central gateway. So what we can do is we can connect to IoT hubs. We can then make some decisions on it, and then based on the decision, we can then start switching things on and off. But let's start with a quick demo. Okay. Right, so what we're seeing here is IoT Central. I've already created the app, so that's Smart Home and Office is my application that I've got here. At the moment, we've got no devices configured. So let's start by doing that. So the main part of IoT Central is creating devices and what they look like. So I'm going to start off first by creating a device template. So the device template is basically the blueprint of what your IoT device looks like. So I'm going to go I'm going to add an IoT device. But if you also notice, you can get templates out of the box. So if you've got known devices, you can plug these in. If they're IoT plug and play devices, you can plug these in as well. So what I'm going to do, I'm going to create an IoT device. And then I'm going to go next. And I'm going to start with my air quality monitor. Okay, so what you can do now is you can manually import all the settings and type it in manually as well. But what I've also done is I've created my own capability model of this device. So this would be a manufacturer creating a capability model and giving it to you so that you don't have to worry about it. So I'm going to import one, and my device I've already modeled is a Pimoroni Enviro Plus. So I'm going to open this. So what you see here is the capabilities of this device now. So I can now support telemetry coming in, temperature, pressure, humidity, and all those nice gas things, and all those particulates as well, PM1, 25, and 10. The type is telemetry. And what we can see is we can see the semantic types also filled in for like temperature and things like that. Okay, so this is a model of a device. So the device is going to be pushing in information. So it's coming from an IoT Central firmware. So it understands the formats that's required for this. So, and all you have to do is have your device match your model. Now, I spoke about views before. So I'm going to go to views. I'm going to generate default view. So what I can also do is, based on that model, I can say, well, build me a view. So here we go. I've done that. So if I go to overview now, it's actually then taken that definition and made it into nice graphs. And the graphs of temperature, pressure, humidity, and light, and I've got little boxes that's going to pop up with information and things like that. So this automatically generated this from that model, and it visualized it quite nicely. Okay, so now what I can do is I can say, well, this is version 1 of my device. Let's publish it as version 1. So I'm going to publish. Okay, right. So now I can say, well, let's take that device template and make it into a real device. So I'm going to say, well, I'm going to keep it by default and go create. Right. So now I've got a real device. So this device here is a device that would be running. So I'm seeing it waiting for data and things. Let's actually connect a device to it. So what I've got, I'm just going to open this camera. So I've got a down camera here that's watching this IoT device. There's my Enviro Plus. I'm sitting next to a Sonos switch. So what I'm going to now do is just quickly tell that device what its, and the important thing is what its device ID is and what its scope ID is and its key. So I can just go in IoT Central. I can go to connect. I can go grab its device ID. And I can go over here, paste the device ID. And then I'm going to grab this key and then paste it. Yep. Right. Now let's save that. So what I've done now is I've just told my device what the device definition is. So in other words, its identity. So I've told it now to connect to that device ID that's within IoT Central. Okay, let's just see what's happening. See if there's anything good happening here. So it looks like it's connected. Oh, it's got some telemetry as well. It's now sending telemetry to IoT Central. Okay, put that away. So now if I start seeing raw data, I have some telemetry coming in, which is very cool. Right. So what I'm going to do now is while I'm collecting some telemetry to populate those graphs, I'm going to create my next device, which is my gateway. So I'm going to go back to device templates. I'm going to make a new device, follow the same process I did before. And then I'm going to say, well, I want my gateway. And I'm going to create my gateway. I'm going to import my capability model that I created with my gateway, my home office gateway. So now what I've got here is this gateway can accept two commands. And looking at this, it's a turn device, gateway device on. I can pass in a device name, and I can also switch it off. So this is now commands that I've got that I could potentially run. So I'm going to publish this as well and create this into a real device. So I'm going to go to devices. I'm going to say new device. It's going to be of type home office gateway. Okay, let's do it this way around. Okay, home office gateway. And I'll get a nice friendly name at least. Okay, cool. Gateway. Right, so that's my device. Now I've got this node red that's here, and it's got a connector here to a device. What I'm going to do is tell it what this device ID is as well. So I'm going to go connect. I'm going to grab the device ID. Device ID. The only important thing that I need is the key. Okay, paste the key here. So now what I can do is I can deploy this and let's see if it runs. Okay, let's just wait. It's connected. That's always a good sign that it's connected. Cool. So I'm going to go now to my gateway. Let's see if our gateway is working. So let me bring my camera here. Place the camera like that, and let's paste this like. Oops. Okay, so I've got these commands that I can run now. That's going to now speak to my switch. It's going to speak through that Node-RED gateway, and I could say something like sign off minus light. Just remember that was the name of my device. And if I had to say turn device on, oh, there we go. I've got a desk lamp facing down. And we can see here that the two little lights are coming on as well. So there we go. We've got the device on. What I can do is I can try and test to see if my switch off works. There we go. It went dark. So that looks like it's working as well. The one thing about these online sessions is I can't hear any applause, but I will continue. Now I've got maybe another device connected. So I've got an Aircon. I haven't really got an Aircon to show you. So if I run this, I should now have a red light that pops up. So this is my Aircon switch that's switched on. And I can switch that off as well. So now I've got this nice system working now that IoT Central can now speak to a device. And I can send messages up and down. So let me go check now and see if my air quality monitor has received enough telemetry to make sense. It looks like it has. So here's my air quality monitor populating some information on the screen. So here we've got some temperature coming in, some humidity and things like that. So what we've got is a nice dashboard as well that we can view things in IoT Central. It hasn't got a lot of information because we just created this device now, but it's populating quite nicely here with information. Okay, so that part of it is working. So now what we can do is take this further and we can go to our PowerApps and we can say, go to the Power App. Now I'm going to create a new app, new Canvas app. And what I can do is I'm going to make a new phone layout application.
Hi, Alan. I'll just interrupt in between. I'll just remind you we are like 10 minutes to go for this session.
Okay, cool.
Yeah.
And any questions? Okay, right.
There's
So here we go.
Yeah.
Okay, right. So what we've got here is our Power App. What I can do here is I can say, well, and the important thing is first, I can go to settings, I can go to advanced settings, and I can set my dynamic schema. I can go here and I can say enhance formula bar. The only problem with this is now I have to go save this and then just refresh, otherwise it doesn't apply. Okay, so let's just go make sure it refreshes. Okay, right. So I've done that. So let's go back to my app. I'm going to go edit it. And while that's going, let me create a flow. So let me go create a flow. I can say new flow. I'm going to create an instant flow. And I'm going to call it turn gateway device on. And I'm going to say it's triggered by PowerApps. I'm going to create. I'm going to make a new step. And seeing I've already got the connector for IoT Central, I can go to the connector. I can say execute device. Execute device command. Seeing it's in my tenant, I can now look up IoT Central. I have to answer it in this weird order because it's based on this. So I can say home and I can now say, well, what component do I want? I want that interface. I want the device command to be turn device on. And this command here, I want to say ask in PowerApps. And this device name, you notice that it's dynamic. It populated this, and basically, well, it grew based on what came out of this interface that was defined. If there was 4 parameters, it would get 4 bigger. So I'm going to say with this one as well, we can also ask in PowerApps. Okay, so let's say that. Okay, so now I've got a flow. So let me go back to my app.
Hi, Alan. Quick time check. We have 5 minutes left for the session.
I'm going to switch on the light in 2 minutes.
Sure, yeah. I'm waiting for that.
Right, so what I'm going to do now is I'm going to say, well, I want a button. I'm going to put the button down. And what's cool now is, let me say, on, and the actions that I can use is Power Automate. And I could say, turn the gateway device on. It's going to add it now to our formula bar. Hopefully soon. Okay, so now it's got our parameters. So what I'm just quickly going to do is just grab our device ID. We need our device ID, which is this one. And I'm just going to say Sono. Oh. So now where's my camera? Oops. Put this to that side of the screen. Let's make that bigger, make this bigger, and we should be able to turn on light. Woo! And there we go. And we can do the same for telemetry as well. Yeah, display telemetry, set information. There we go. Is there any questions? Whirlwind tour of
no questions
IoT.
So far.
Yeah,
No questions
there's resources here as well. Yeah, so there's resources here as well. So if you're interested in any of those portions, there's URLs here. I'm sure we're going to share the slide decks, right, Roma?
Yes, Alan.
Okay, cool. No questions.
But that was pretty awesome. I was watching it for the first time, how the combination of, the PowerApps and IoT has come together and is working, because most of the time we don't see this combinations pretty in sessions, and this is pretty amazing. Especially when the lights turned on, the magic happened.
Yeah, what's impressive is you can do it without any code. There's absolutely no code involved.
Yeah, I will just add to what Roma was saying. That's a great session. I did one thing which I remember a few years back around field service, and there was a temperature gauge, right? And it's just an extension in a low code way to that kind of an approach. Great session, Ellen. If there are any queries, Roma or Shalini, let me know. Otherwise, let me know once we want to stop the recording.
No queries as of yet.
So
thank you very much for having me.
Thank you,
Alan.
Alan.
Thank you so much.
Thank you so much,
Alan, for joining.
And joining and sharing your knowledge with us. So can I stop the recording then, guys?
Yes, please.
All right, cool.
Cool. Thank you very much.